this chapter, we will be looking at topics related to measurement. In this lesson, we will be looking at how to determine the surface area and the volume of composite solids.
All right, so as was said here, in this particular lesson here, we're looking at composite figures. We're putting things together here. There's really not much explanation that goes into this, but I know that this can be a difficult thing for some people here because it's hard to kind of deconstruct these shapes in our heads and then put together the pieces that you're being asked for. This really requires just practice. You have to do it a few times, and then after a while you start to get used to what's going on and what part is missing from the equation and so on and so forth. Now, this particular lesson is broken up into two parts here. In the first section here, we're being asked to find the volume of each object, and then we're asked to find the surface area. But you know what? What I want to do with each of these is I'm going to do both. Okay, as I lead this through with you right now, we are going to find the volume and the surface area of all of these things at this, kind of with each question here, just so that we get as much practice as we can with this. Okay, so now let's just basically just jump right in. Okay, we'll start to do this first one here. We're going to find the volume and the surface area of this thing right here. So first of all, we're going to look at the volume. Notice that this is a hemisphere on top of a cylinder. And so we're going to have to put the two pieces together here. So the volume of a hemisphere is 2/3 pi r cubed. Important that you remember that this is cubed, not squared. Plus, and then the volume of the cylinder is going to be pi r squared times the height. So now in this case here, this will be 2/3 pi. Well, the radius there we're told is 4, so 4 cubed. Plus pi times the radius of the hemisphere and the radius of the cylinder are the same. Okay, that's part of what makes it nice about these composite shapes here. Okay, they're going to typically share some properties here. And then the height is going to be 11. And now, really all I got to do with this is plug this into my calculator and evaluate. Okay, so so we'll just enter this in. Make sure you can see the equation there. So this will be 2/3, close that up, times pi times 4 cubed plus pi times 4 squared, got to get out of the exponent there, times 11. Press enter. Okay, and so now to the nearest tenth, we're getting 687.0, approximately 687.0. And what are our units here? Centimeters cubed. Okay, good. Now let's take a quick look at the surface area of this shape. Okay, now, I've got a hemisphere and a cylinder here, but parts of it are lost in the overlap. Okay, that circle part of the hemisphere is not open. The only part of that hemisphere that's exposed is that circular part here. Now remember when we put together that formula for the surface area of a hemisphere, it was 2 pi r squared plus pi r squared. Well, in this case, we don't need that pi r squared. So this is simply going to be 2 pi r squared just to deal with that curved part of it. And then we're going to add to this the surface area of the cylinder. But remember what the surface area of a cylinder is. It was 2 pi r squared plus 2 pi r h. Now, the 2 pi r h is this part. Okay, 2 pi r h. Oh, sorry, whoa. Nope, I don't know why I did that. Ignore that, pretend I didn't write that. 2 pi r h. Now, the 2 pi r squared deals with the bottom circle and the top circle, except the top one isn't exposed. It's only the bottom circle. So that's just the 1 pi r squared. So over here, we're going to add 2 pi r h plus pi r squared. And now I'll fit in everything I know. I know that the radius here is 4, so this will be 2 pi 4 squared plus 2 pi times 4 times 11, the height, plus pi times 4 squared. And okay, granted, I could simplify this because I've got some like terms here, but you know what? I'm just going to enter this all in because I want to get an answer to the nearest tenth. I'm going to be sticking with that. And so here, what we've got here is 2 times pi times 4 squared plus 2 times pi times 4 times 11 plus pi times 4 squared. All right, looks good. Press enter. And now to the nearest tenth, our surface area is 427.3. 427.3 centimeters squared this time, because we're talking about surface area. All right, just like with the previous question, we're going to find the volume and the surface area of this shape here. And actually, this one is very comparable to the one above it, really, in terms of what we're doing here. We've got the one shape kind of on top of it, the other one here. This one here looks to be a rectangular prism, or actually, sorry, I guess the better way to describe it would have been a square prism, because it's got a square base here. Either way, however you want to look at it here. And then we've got this pyramid on the top. Now, this is definitely a rectangular pyramid, because this line and this line aren't the same length here. But anyway, to start off with, our volume, it's going to be the volume of that pyramid, which will be 1/3 area of the base. Sorry, I've just finished establishing that that was a rectangular pyramid, so this will be length times width times height, plus the volume of the base here, and we'll call this a rectangular prism for the time being. So this will be length times base times height, and so we get 1/3. The length is going to be 15. The width would be 13, and then we are told in this case what the height is. It's 12. We don't need to use the Pythagorean theorem to figure that out. And then the length of the prism down here will be 15. Times the width of 13 times the depth of 13. And now putting that all together on the calculator, and this is actually quite straightforward here. 1/3 of 15 is going to be 5, so times 13 times 12, plus 15 times 13 times 13. We get a nice number, 3,315 feet squared. Good. Now, let's take a look at the surface area. Now, I haven't given myself a lot of room off to the side, so I'll just do it right here. So my surface area is going to be the surface area of that pyramid, but in this particular case, only the lateral sides are showing here, okay? And so I don't need to worry about that base there. So what I've got here is I'm going to have two triangles. Now, I'm going to have to figure out the slant height here and the slant height here. Okay, so this is going to require a little bit of the Pythagorean theorem. So let's start off with the one at the front here. Okay, remember we called this A in the past here. So for this triangle right here, if I was to carry this line all the way through, I know that would be 13. So that makes this right here 6.5. That base right there. So I know in this case here that 6.5 squared plus 12 squared is going to equal A squared. Okay, so now I'm just going to do this on my calculator. 6.5 squared plus 12 squared. And A is going to be the square root of that. So I'm just going to give it as the decimal that I get here. When I square 6.5 and add it to 12 squared, I'm going to get 186.25. A is going to be the square root of that. Bear that in mind. I'm going to use that in just a second here. Now, to get this length here, and in the past we called that S. When I look at that triangle right here, if I extend this side all the way across, that would be 15. So the base of this triangle here is going to be half of that, so 7.5. So I know 7.5 squared plus 12 squared, whoops, I could have written that nicer. 7.5 squared plus 12 squared is going to equal S squared. And just like I did before here, I'm actually going to evaluate that and figure out what that number is. So 7.5 squared plus 12 squared equals, this is going to end up being the square root of 200.25 for S. So those are the two slant heights right there. So now, here we go. I have got two triangles that correspond to that front one. So it's going to be 2 times 1/2. And I could have simplified that, but it's not bad to see that every once in a while. The base is going to be 15, and the slant height here we discovered was the square root of 186.25. Okay, now we've got the other two triangles, so it's going to be 2 times 1/2, and again, I could have simplified that, but whatever. The base in this case would be 13, and the slant height here we discovered was the square root of 200.25. Oops. Now, that just takes care of the four triangles, the two that are front and back and the two that are left and right here. Now I got to deal with the sides, the exposed sides around this rectangular prism. But that's actually not too bad. If we take a look at this front one here, this one that's 15 by 13, there will be two of those. So I'm going to have two 15 by 13. The left side and the right side are going to be 13 by 13, so I'm going to have two of those, two 13 by 13. Now I'm running out of paper here. So let's look at the base here. But the base is going to be 15 by 13 too. There's another one. That base is the same as that side here. So what I can do here is actually just change this number here. I've actually got three of those. And so now I can just plug this all right into my calculator exactly the way I see it. Now there's no really division here, so I just got to plug this in. Okay, I know 2 times a half is just going to be 1, so I'm going to jump right to 15 times the square root of 186.25 plus 13 times the square root of 200.25 plus 3 times 15 times 13 plus 2 times 13 times 13. Oh, there's a lot going on there, but the calculator can handle it. I don't have to worry about it. Just make sure that I've broken things up with the plus, the addition signs the way I want to. Press enter, and to the nearest tenth, I get 1,311.7. Approximately 1,311.7 feet squared is the surface area. All right, so in this case, we have got a cone over a hemisphere. So we're going to have to figure out, again, the volume and the surface area. And the volume, again, relatively straightforward because there's two complete shapes here. With volumes, you're just going to add them together at this point. So the volume of the cone will be 1/3 pi r squared h, 1/3 of the corresponding cylinder. And the hemisphere, we already know, is going to be 2/3 pi r cubed. So 1/3 pi, well, now bear in mind what this means here. When they point to this, that line goes all the way across there. So the implication here is that that's 30 is a diameter, not the radius. So I need to divide that by 2 to get the radius. And then the height there at 37. Okay. Now add that to 2/3 pi, and again we know that for that hemisphere that radius is going to stay the same. And there we go. I just got to plug that into, oops, sorry, you can't see that. I got to plug that into my calculator here. So that will end up being 1 divided by 3, oops, times pi times 15 squared multiplied by 37 plus 2/3 multiplied by pi multiplied by 15 cubed. Okay, everything looks like it's there and in place. Press enter, and there we go. To the nearest tenth, 15,786.5. So approximately 15,786.5 millimeters cubed. Now let's take a look at the surface area. Okay, well, the surface area of the hemisphere is actually going to be relatively straightforward. We're going to lose the circle there that normally gets included. It's the cone that's the problem, because in order to figure out the surface area of the cone, the lateral surface area, I need the slant height, and I don't have that. So again, I have to use the Pythagorean theorem. And on this exam, when you get to this point here, as you find yourself working through it, if you find that you get to the end of this exam and you didn't use the Pythagorean theorem, you very likely did something wrong somewhere along the line there. So be on the lookout for it. This is going to happen. So this should be 15 squared plus 37 squared is going to equal the slant height squared. So I'm just going to evaluate that, 15 squared plus 37 squared. And I'm not even going to bother simplifying this. I'm not even so sure it can be right off the top of my head. That's going to be the square root of 1,594. We'll use the positive one there. And that's fine. I'm just going to leave it like that because I can plug it into my calculator when I need it. So the surface area, well, the surface area of the cone, I only need the lateral surface area. So that's going to be pi rs. And then with the hemisphere, same thing with this one. I don't need that circle. I don't need that base. I only need the half of the sphere. So in this case, 2 pi r squared. So when I when I plug these things in here, that'll be pi times 15 times the square root of 1594 plus 2 times pi times the radius squared, 15 squared. And again, we just go to the calculator. Here we go. So pi times 15 multiplied by the square root of 1594. Got to get out of the square root. Got to finish that up. Plus 2 times pi times 15 squared. So there's our cone, the lateral surface area of the cone. There's the lateral surface area of this hemisphere. Press enter. And to the nearest tenth, it's approximately 3,295.1 millimeters squared. All right, here we go. This next one right here is, this is a square pyramid over now it's not quite a cube. Okay, it's close to a cube, but it is a square prism here. So here we go. The volume is going to be the volume of that pyramid, so 1/3, and 1/3 the corresponding prism here. So it'll be base squared times height. Now the height of that is going to be a little different than the height down here, but the square pyramid is going to be base squared times its height. So I might put, like in this case here, the bases are the same, but this height will be different from this height. So we'll put height 1 and height 2 just to be clear. Now let's take a quick look at this pyramid. This will be 1/3. The base is 10, so 1/3 10 squared times the height. Well, okay, this is what I'm looking for. I want the height right there. Okay, I want the height right there. That 9 is the slant height. So that becomes my hypotenuse. Now, if I extended this bottom line all the way across, I know that would be 10. But it's not all the way across. It's got to be 5 then. So let's use the Pythagorean theorem. So h squared plus 5 squared is going to equal 9 squared. And so what I got to do is just isolate the h squared here. And when I do that, I'm going to get h is going to equal the square root of 56. It'll be the positive square root, even though there should be both of those. Because 81 minus 25 is going to be 56. And again, I can simplify that. I totally could. But I'm just going to enter it in like this. So come up. That'll be root 56 plus the volume of the square prism down here is going to be 10 squared, and its height is 11. It was given to us. It was wonderful. So now I can just plug this into my calculator. So 1 divided by 3 times 100 times the square root of 56 plus 100 times 11. Really didn't need to do that, but there we go. And so the volume to the nearest tenth will be 1,349.4 centimeters cubed. Okay? Now, we would also like to figure out the surface area. Now, what's nice about this question is that the surface area, when we ask for the surface area, is that this is a square, this up here is a square pyramid. So all 4 of those sides, those triangles, are going to be the same here. So this will be 4 times 1/2 the base times the slant height. In this case, they give you the slant height there. We're good. So that actually, in this case, the lateral surface area of that pyramid is actually quite easy to figure out. Now, it's going to take us a little bit more time here to figure out the surface area down here. Bear in mind that it's not a cube, so these sides here are not all the same. In fact, all the way around here, the height of all those things is going to be 11. So there will be 4 sides, okay, where we're going to have to multiply base times height, and then we're going to have base squared at the bottom there. And so here we go. So this will be 4 times 1/2. I know I could have simplified that anyway. The base of each of those triangles is going to be 10, and the slant height is 9. The base for each of those rectangles there will be 10, the height would be 11, and then the base there is 10, so 10 squared. And so we'll just enter that all in. So we've got here 2 times 10 times 9 plus 4 times 10 times 11 plus 100. And we get that it's got a surface area of 720 centimeters squared. All right, so in this case, we've got a cone over a cylinder. In the previous case, I think it was a hemisphere over a cylinder. So the volume is simply going to be that of the cone and the cylinder together here. So the cone would be 1/3 its corresponding cylinder. And then we've got the volume of the cylinder, pi r squared h. Now it should be noted that these two heights are different, okay? And we'll have to figure that out here because that 5 right there that I'm given, I have to interpret that as being the slant height. So if I want to figure out the height of that cone, I got to know what that is. Now, the radius is going to be the same, so this is going to be 3. So if I want to figure out the height of that cone, okay, I can use the Pythagorean theorem, but actually I probably don't need to, and I really hope that you see this, you see what I'm seeing here. The hypotenuse is 5, one of the sides is 3, the other one has to be, and I'm going to just wait for a second there, think about it, 4. Okay, that is a Pythagorean triplet. So this becomes 1/3 pi 3 squared, and the height of the cone is going to be 4. Whoops. 4. Now, for the volume of the cylinder down here, all the information is given to you. It's going to be pi r, sorry, I'm plugging that in now. Pi times 3 squared times 6. And so now we just plug that all in. So 1 divided by 3 times pi times 9 multiplied by 4 plus pi times 9 times 6. And we get, to the nearest tenth, 207.3 centimeters cubed. Now, to figure out the surface area, again, it's a matter of looking at this composed shape here and realizing of the composed pieces, what pieces aren't present. So for example, for this cone, think about the surface area of a cone. It's pi rs plus pi r squared. But in this case, the pi r squared part doesn't exist. It's not an exposed face here. Only the lateral part is. So all I need here is pi rs. For the cylinder, okay, remember that the surface area of a cylinder is 2 pi r h plus 2 pi r squared. Well, the 2 pi r h, that is there. Okay, that is the lateral area. Okay, if this was a can, that'd be the part that you would grab. The 2 pi r squared is the circle at the bottom, circle at the top, but that circle isn't exposed. Those two are covering each other up here, so I've only got the one circle, so I'll be adding just pi r squared. Now if I plug everything in, that's pi times 3. And in this particular case with the cone here, they gave you what that slant height was, plus 2 pi 3 times 6 multiplied by, sorry, added to pi times 3 squared. Now I just enter that all into the calculator. Pi times 3 times 5 plus 2 times pi times 3 times 6 plus pi times 3 squared. And to the nearest tenth, I get 188.5 centimeters squared. And there you go. I do know, and I do recognize that for some people that these composite shapes here can be very, very difficult. I get that. Keep working at it. Tell you what, I'm going to show you one more here. Okay, I'm going to do one more here, and I know this wasn't specifically part of the notes, but I want to include this one here because this is a good problem here. Let's say you had a cube that was 10 by 10 by 10. I don't know what the units are. It doesn't really matter here. And then I drill a hole through it that's got a radius of 2. Okay, and it's clear through. Now the question is, what are the volume and the surface area here? Now, in most of the composite solids that we've done thus far, we have been adding the pieces together. But if I want to figure out the volume of this shape here, it's going to be the volume of the cube, so that's going to be my edge cubed. This time I'm going to subtract the volume of that cylinder. So I'm going to subtract pi r squared h. So in this case here, this is going to be 10 cubed minus pi times, well, the radius of that cylinder there is 2 squared. And then the length, or the height of that cylinder, would be 10. Now I just plug that into my calculator, no big deal. So it's going to be 1,000 minus pi times 4 times 10. And the value we get to the nearest hundredth, sorry, the nearest tenth, I should say, nearest tenth, will be 874.3 units cubed, whatever those units are. Okay, so just here's an example of a little bit of subtraction here. Now, that's all well and good. Volume is not typically all that hard, but surface area is going to be a little bit more difficult here. Okay, because we got to think this thing through here, because when I drilled that hole through, I eliminated those circles, but I introduced, like if I was to stick my finger in there, I could touch the inside of that cube. There would be the lateral surface area of that cylinder is exposed, even though the circles have disappeared. So there's a little bit going on here. So let's just take a look at it like this. If we were to get the surface area of the cube, that would be 6 times the edge squared. Now, the cylinder has got those 2 circles at the edge, but I got rid of those. I drilled through those. So I'm going to subtract 2 pi r squared. But then the act of drilling that hole exposed an inner surface. That is the lateral surface area of the cylinder. And so I'm going to add to that 2 pi r h. So you can see here, you really need to understand what the pieces of those surface area formulas are referring to so that you can adequately pull out the pieces that you need. So in this case, this is going to be 6 times 10 squared minus 2 times pi times 2 squared plus 2 times pi times 2 times h, which in this case was 10. And so now I just go to my calculator to figure this out. 6 times 10 squared minus 2 times pi times 4, it's going to end up being 4, plus 4 times pi, because I got the 2 times the 2, times 10, and I'm getting that this is, to the nearest tenth, 700.5 units squared, approximately. I hope that made sense. I hope that made sense. Take some time. Do go through the assignment. Practice with this sort of a concept is really the only way that you're really going to get your head wrapped around what you got to do with each question.